For number 6 on the study guide, it asks us what would be the vertices of an image if the pre-image has vertices at A being 2, -2, B at 1, 2, C at 3, 3, and D at 5, 2, and they were reflected across the x-axis. So we need to remember our rule. So the rule that goes along with reflecting over the x, remember, reflect over x, x stays the same. Reflect over y, y stays the same. So if we're reflecting over the x stays the same, y changes. So what I'm going to be looking for is all of the vertices that have an opposite sign for the y value. So if I was going to write them out, A would be at 2, the x stays the same. I'll take the opposite sign for that y. So instead of -2, it'll be +2. B, my x will stay the same. I'll take the opposite sign for my y. So instead of +2, it'll be -2. C will be x stays the same, opposite sign for y. And D, x stays the same, opposite sign for y. So when I say opposite, what I really mean is I'm taking, if it was positive, it becomes negative. If it was negative, it becomes positive. We're taking the other sign. This does not mean -y. It means opposite of y. So if you have a -2, you're going to take the opposite sign. So opposite of negative is positive. So now I'm going to compare that. And it seems like this is the only one where my A prime, oh, I forgot my primes. Where my A prime is going to be 2, 2. This is actually a typo here for number 6. This is supposed to be +1, -2. And then C prime is 3, -3, and D prime is 5, -2. So this is the answer, but it is a typo. B prime should be 1, -2. For number 7, it says what would be the vertices of the image if the pre-image had vertices at A, B, C, D, and they were rotated 270 degrees counterclockwise about the origin. So what we need to remember here is if we're talking about 270 degrees counterclockwise, then we are in good shape because our rules and our wrap both deal with counterclockwise. So if we have counterclockwise, we're good to go. 270 degrees, find the opposite of x, switch the x and the y. So this is your rule. If you needed to draw this out on a piece of graph paper and then turn your graph paper around, you could do that too. For instance, let me grab a little sticky note. If I'm going to say A is at 2, -2, B is at 1, 2, C is at 3, 3, and D is at 5, 2. If you can't remember the rule or you have a hard time with it, that's okay. Draw something out on a side piece of paper and watch. If I go 270 degrees counterclockwise, that means I will need to rotate to the left because clockwise goes to the right, counterclockwise goes to the left. So this was my original. If I turn my paper one turn to the left to where my side becomes now my new bottom, this is going to be my new x-axis, this will be my new y-axis, where A is going to be at 2, 2 instead of 2, -2. So again, this was our original. This is 90 degrees. This is 180 degrees. This is 270 degrees. 360 would bring us back. So this was 270 degrees counterclockwise, which means I turned to the left. Now, if I pretend like this is my x-axis and this is my y-axis, I can just say, okay, I know A is going to be at -2, -2. And looking at my options, there's only one A prime that has -2, -2, which would be C. But I can compare that with the rest of my coordinates. B would be at 2, -1. C prime would be at 3, -3. And D prime would be at 2, -5. So you can always graph it out that way. Or what you could do is you could apply the rule to our vertices. So A, my y goes first, So my y goes first, so a prime, y goes first, which is -2. Then I take the opposite sign for my x. So instead of +2, it becomes -2. For b prime, my y goes first, so it's 2. Then I take the opposite sign for my x, which instead of being +1 is -1. If I do c prime, my y goes first, so 3 goes first. Take the opposite sign for my x. And d prime, my y goes first, and I take the opposite sign for my x, which is the same thing we got when we rotated our paper around. Either way will work for you.